And we're back with video lesson number 6 on kinetic energy and temperature. So the key question is, what is the relationship between the temperature in Kelvin and the average kinetic energy of particles? So let's take a look at that. When a substance is heated, its particles absorb energy. Some of the energy it absorbs is stored within the particles. The stored portion of the energy, or the potential energy, does not raise the temperature of the substance. So think about that. Okay, so you have all this energy coming in. Some of it is being stored, and that is the potential energy. The remaining energy then is going to speed up the particles, and that increases their kinetic energy. If it increases their kinetic energy, it will increase their temperature. The particles in any sample of atoms or molecules at a given temperature have a wide range of kinetic energy. Like, they're not all moving at the same speed. Most have kinetic energies somewhere in the middle of that range. So we use the average kinetic energy when we're discussing the kinetic energy of a collection of particles in a substance. So if we're looking at the entire number of particles as a whole, we look at the average kinetic energies of that collection of particles. So at any given temperature, the particles of all substances, doesn't matter what the physical state, have the same average kinetic energy. So the average kinetic energy is directly related to the substance's temperature. An increase in the average kinetic energy causes the temperature of a substance to rise. As the substance cools, then the particles are going to move more slowly. Their average kinetic energy is going to decrease. At absolute zero, which is called 0 Kelvin, Kelvin with a capital K, which is equal to negative 273.15 degrees Celsius, is the temperature at which the motion of particles theoretically stops. The particles quit moving. No temperature can be lower than absolute temperature, and right now absolute zero has not been produced in a laboratory. However, a near zero temperature of about 0.1 nanokelvin, now nano is 1 times 10 to the minus 9, so it's really, really small, has been achieved. And with that is the end of this video lesson, so have fun, be happy, and dance with me. This is Mrs. Weethy, so long for now.